In this video, let's see the orthogonal trajectory of the family of curves r power n is equal to a power n cos n theta. Previous video, we have seen in Cartesian, but here it is in polar form. Given curve is in polar form, that is in terms of r and theta. The procedure is the same, but there we will replace dy by dx as minus dx by dy. Here we will replace dr by d theta by minus r square d theta by dr. This is the difference between Cartesian and polar. Remember, in Cartesian, it will be in terms of x and y. Okay, so Cartesian will be in terms of x and y. There we will replace dy by dx as minus dx by dy. But here we are replacing dr by d theta by minus r square d theta by dr. So as usual, what is step 1? We are going to differentiate with respect to theta. Differentiate with respect to theta. And remember, power is there. And then because your question is r power n is equal to a power n cos n theta. Correct? Let me check the question. R power n. So now whenever you see, whenever you see in polar, what we will do before differentiating? We will take log on both sides. Same way, and then we will differentiate. Take log on both sides. First we will do this and then we will differentiate with respect to theta. Because we have a power, so it is tough to differentiate with the power. Now, log of r power n is equal to log of a power n into cos n theta. We have two properties of log, that is log m power n is n log m. Let me write here, log m power n is n log m. We are going to use this. So this power over here will come down. N log r is equal to, and the second one is log of a into b is equal to log a plus log b. So here log of a power n plus log of cos n theta. Now we are done with the log function. Now we can differentiate with respect to theta. Hence, this n is a constant. I'll write as it is. And then log r differentiation is 1 by r. Because in polar, r is also a function of theta. So I cannot take r as a constant. So we'll write 1 by r into dr by d theta. That is equal to log of a power n. This is completely a constant. So if I differentiate this, what I will get? 0 plus log of something. It means 1 by that something into d by d theta of cos n theta. And remember, this is a normal differentiation. This is not partial. And this r is not a constant. Always in polar form radius of curvature. Already I have told you that this r is a function of theta. So we can't take this r as a constant. Only keep that in mind. Now, let me simplify this. 1 by r into dr by d theta. Let this be n is also here, right? That's equal to 1 by cos n theta. Cos n theta differentiation is minus n sin n theta. This side n and this side n, anyhow it will get cancelled, which implies 1 by r dr by d theta is equal to tan n theta. Sin by cos is tan. Now your step 1 is over, that is we differentiated with respect to theta. Now your step 2 is replace dr by, now we got the differential equation, right? Dr by d theta by minus r square into d theta by dr. Procedure is the same. So after replacing, what we will do? This differential equation again we will integrate to get the required orthogonal trajectory. Correct? So 1 by r into, in the place of dr by d theta, minus r square into d theta by dr, that is equal to tan n theta. Let me cancel this and this. 1r will get cancelled, and then we get r into d theta by dr is equal to, and right hand side we have cos differentiation is sine by cos is this minus sign I missed to write. This minus sign is here, this minus sign is here. This minus and this minus will become plus. It will get cancelled and we will get only plus tan n theta. This side minus and this side minus got cancelled. Now this is a differential equation. Now what we are going to do? We are going to integrate using variable separable, because this is very easy. R into d theta by dr is equal to tan n theta. What is yours? Integrate. This is your step 3. We are going to segregate. So what we will do? Push this d theta to the other side. Then what we will get? D theta by tan n theta. Let me write like this. Tan n theta is equal to dr by r. Now if I integrate, it is easy. Just we are taking this tan n theta here and this dr again back in the numerator. So this will come to the denominator. And we have a constant also, right? Let me write. What is dr by r? Dr by r is nothing but log r. And what is integral of cot n theta? Because let me rewrite one more. Cot n theta d theta. Okay. And because 1 by tan is cot. And the integration of cot n theta is log of sine n theta. And then that n theta constant is there. It will come to the denominator. Now, if you see here, you can write it as log r minus 1 by n into log of sine n theta. And this constant c, if I take it to the other side, I can write it as c1. So minus c is c1. I can rewrite this. It's our wish. We can add the constant to any side. Now, if I take LCM, what will happen? N into log r minus log of sine n theta is equal to n into c1. Now you can see this, that is, this n goes to the power log r power n minus log of sine n theta is equal to n into c1. And now we are going to use the property, that is log a by b is nothing but log a minus log b. So we are going to use this property over here. So this implies log of r power n by sine n theta is equal to nc1. But when I can compare, this means this side also should be in terms of log. So instead of nc1, what I'm going to write it, this as a log of some k. Log of, because this is also a constant, this is also a constant. This nc1, I'm replacing it as log k. Now it is easy for us to compare the constant. So this is r power n by sine n theta. If I compare, what you will get? R power n by sine n theta is equal to k. Because log A is equal to log B means obviously A is equal to B, which implies R power n is equal to k into sine n theta. And this is the required orthogonal trajectory for k sine n theta is the required orthogonal trajectory for the given family of curves. And this is the question, r power n is equal to a power n cos n theta. And remember, Cartesian, we'll replace dy by dx by minus dx by dy, and polar we replace dr by d theta by minus r square into d theta by dr. This is the only difference. And self-orthogonal means after replacing the required values, either it's in Cartesian or polar, the new differential equation also will look similar to the existing differential equation. Then we can call it as self-orthogonal. Thank you.